Hi, in this lesson, we're going to discuss net figures. Before we can talk about net figures, we need to address two kinds of shapes, a prism and a pyramid. Now, the key difference between a prism and a pyramid is a pyramid, you can hang a star, put a star on top, and a prism, a little miniature person could sit on top. Now, we all know what the Pyramid of Egypt looks like. So let's think of the Pyramid of Egypt. It looks something like that. The very top of it. See how it comes to a point? You can't sit there, but you can put a star on the top, just like a tree. If you can put a star on the top, the shape is a pyramid. If you cannot put a star on the top, but instead you could sit on the top, so for instance, this figure, you see how you couldn't hang a star on the top of that because there's no point? It doesn't come to a point like the pyramid. Instead, you could sit right on the top of this one. A little person could sit right out there in the middle comfortably. That means it's a prism. Anything that is like the Egyptian pyramid comes to a point at the top and you can sit on it and you can put a star on it. Excuse me. That is a pyramid. You can't put a star on the very top point, you're not a pyramid. You're the other one. It's easy to just know what the pyramids look like and associate that pointy top with pyramids because of the Egyptian pyramids. And you can put a star right up there on that. You can't sit on it. It will be uncomfortable. Now, once we talk about prisms and pyramids, either one of those are named according to the shape of their base. So if I was going to pencil in the base, this would obviously be something you can't see because it's hidden. Do you see how the base of that is a rectangle? This part that sits on the ground, so that is a rectangle. And then over here on our box, the base of it is also a rectangle. So if we just look at the bottom, what's sitting on the ground, that part right there, that is a rectangle. Both of these are named by the shape of their base. So the one on the left is a rectangular prism, and the one on the right is a rectangular pyramid. They both have the same shape on the base, a rectangle, but they have different tops. One comes to a point, one is flat. There's the difference between a prism and a pyramid. Now you can have other shaped bases. You could have a square, in which it would be a square prism. That would be like a cube. Or you could have a square on this pyramid, it would be like a square pyramid, and the base would just be a perfect square and not a long base. Important to know, a rectangular prism is a cereal box. A square prism is like a die or a cube, okay? But now what about other shapes, other polygons? What if you had a base that was a hexagon? And this might be a challenge for me to draw, but we'll see. Hexagon is 6 sides. And let's just say that this is a hexagonal something. I want you to tell me what kind of shape this is. What is that? Is that a pyramid or a prism? Can you put a star on the top? Yes. Therefore, it is a pyramid because the top of it is shaped just like the Egyptian pyramids. What's the base? What shape is the base? A hexagon. So this is a hexagonal pyramid. Now, if the top of that was a flat hexagon itself and it didn't come to a point, then it would be a hexagonal prism. Now, as we're considering these different shapes, we need to discuss what happens when we cut them at the seams and make them flat. So I'm sure you've had a cereal box that or a carton of pop or a 12 pack of pop that you had to cut the box open so that it would go flat into the trash can. Probably your parents say, squish that box, break that box down. Those mean take that box apart so it doesn't take up as much room in the trash can. So let's look at some net figures, and I specifically want to look at the net figure of this rectangular prism. So I'm going to get rid of my hexagonal pyramid out here in the middle. I don't want it clouding up. Might bring this over. These are our net figures. Prism is something someone can sit on the top of. This is turning out to be more work than it's worth. All this to try to get me some extra room on this sheet. Well, it's not the smartest thing to do. Looking back on this, I kind of wish I hadn't started this, but oh well, I'm in now, so we're going to follow it through. I have successfully moved my cereal box with my check mark where you sit. All right, so if I'm going to cut this cereal box open at the seam so that I can lay it flat, let's take that base or the back of the cereal box, that pink section, which would be right here. And if I cut the sides and the top and everything open, what would it look like? It has to lay flat. So here's one side. Here's another side. We have the bottom and we have the top. Now where does the front of that cereal box go? Where my green check mark is? Well, there's several different places you could put that. I'll just put it right here. That is the front of that. Now let's color code those sides so we can kind of see what we're looking at. And there are other options of how you could cut this open. This left end is right here. We've kind of turned this cereal box around. Turned it around and laid it flat on the table. So this end here is the blue. And that back piece is my yellow. Whoops, that's not right. There's my back piece. That is the net figure. That is the net of a rectangular prism. You are going to get questions that ask you to put those back together. So you're going to be given either the rectangular prism drawing or you're going to be given the net, and you're going to be asked to go back and forth. Now for the rectangular pyramid, it's a little different. So let's see if we can draw a net figure of a rectangular pyramid. So we have our base, and our base is just that rectangle. Why I'm doing that, so I can make a rectangle. And then we've got those pieces that come off of it. Well, what shape are they when you cut them out and lay them flat on the table? What shape would be there? There's my base. On the sides of this would be all triangles. And they're probably all going to be the same length. I just can't get them all drawn that way because of my limited room on the whiteboard. So where's the star? Well, the star could be anywhere. Let's just put the star over there and say it fell to the right. Let's color some of these sides so we can see exactly what we're looking at. So this yellow side would be this one. It's like you took your scissors and cut up the seam. The green side over here would be this one. And then you have the front and the back. And there's your net drawing. Now, what if you have a figure with some labels? So what if you had been given that this was 6 tall, 8 front to back, and 4 wide. And now you have to transfer those measurements to your net. That's not really 6 tall. Excuse me, I misspoke. That's your slant height, not how tall it is. Slant height. So that would translate to this is 4 by 8 on your base. And then every single one of these triangles are 6. All of them are isosceles triangles because they're all the same height and they're all 6. Okay? That really is not possible. That would only be possible if you had a square pyramid. Obviously, those are going to have to be different lengths because anyway, I'd have to think that one out, see if that was possible that they all be 6. It might not be. I don't know. I'd have to think on that. Point being, if you're given the measurements in the picture, that is where they are on the net. Put that 8 in black so you can see it a little better. So you're going to be asked to take those diagrams and those labels, and you're going to be asked to move them from the three-dimensional picture over to the net, or vice versa. From the net, put the net back together and tell me what three-dimensional shape it is, and then label it. Now, another thing that you're going to be asked to do on many of your tests with these net drawings is you're going to be asked what shapes make this up. One of the most confusing ones is this. If I take the net drawing of that, what shapes will I have? So we're going to cut across around the top edge and the bottom edge. And you're going to end up with that. So the net of a cylinder, or let's name it according to what it is it a pyramid or a prism? The base is a circle, so it's a circular prism. But we also call this a cylinder. If you want to be exact and correct, it's a circular prism. It is not a pyramid. One of those cones is a circular pyramid, but this is a cylinder. A net figure is two circles and a rectangle. You see how if you put this back together, you'd have that can again? So let me ask you this. If I give you this dimension, and I say that's 15 centimeters, what's the diameter of my can? What is that 15, really? Remember when we talked about the belt going around your waist, and that's the length of the belt? 15 is the circumference. That's the distance around that can. So if we know the circumference is pi times the diameter. So 15 equals pi times the diameter, just divide by pi. So the diameter is about 5, somewhere around there. 15 divided by 3.14, a little less than 5. You can use your calculator. These are the kinds of things you're going to have to do with these net figures. Another thing you're going to be asked is this. Looking straight down onto a hexagonal prism, pyramid, what shape do you see? That means you are in a helicopter, in an airplane, and you're looking straight down. Got lazy on those eyelashes. So we're going to look straight down onto a hexagonal pyramid. What shape are we going to see? A hexagon. You won't see anything on the top of it. Imagine you're looking straight down onto a cylinder laying on its side. So we're going to look straight down onto a can that's laying over on its side. So actually what you are looking at is this. It's laying on its side. But what will that look like from in the air? What will you see if you look straight down on it like that? Your aerial view of that is simply a rectangle. You can't tell that it's round. All you see is that shape when you're looking straight down onto it. Now, if you turn the can up, set it up now, what will you see looking straight down? Now, when you look straight down, all you see is a circle. You can't tell if it's a tall circle or a short circle. All you see is a circle. So you're going to be asked about things like that. Another thing you might be asked is a silo from far away, a grain silo, well, that's a cylinder from far away. What shape do you see? So if you're looking at a cylinder from far away, really all you can see is this shape here. You can't tell that there's a round top and a round bottom. From a far away spot, all you see is a rectangle. The same as when you're in a helicopter and it's laid on its side. You cannot see those rounded edges from far away. It just looks like a rectangle. You're going to be asked questions like that where you have to picture something from an aerial straight down view or from exactly the side from a long distance away. Put some eyeballs on there. All right, there we go. So that's net figures. Good luck with that, and I will talk to you in the next lesson.